Lastly, I want us to discuss about the applications of pressure. Though we have discussed other two applications, or three maybe, the hydraulic brake system is one of the applications of pressure. Siphon that we have discussed, or we had discussed earlier, is also an other application of pressure. But right now, I want to present to you four applications of pressure in liquids and gases. I'm going to present to you a syringe, the one you are seeing there. I'm going to present to you a bicycle pump, a force pump, and a lift pump. So those are the four that I'm going to present to you, alongside siphon and hydraulic brake system. Before even I continue, I would like to tell you this. As a serious physics student, maybe you are not serious, allow me to speak to the serious students. And sure, when you are told to explain about syringe, like I'm going to do it right now, please be in a position to explain. If you are told to explain the functioning of a bicycle pump, please ensure you know. Atmospheric force pump, please ensure you know. Together with lift pump, siphon, and hydraulic brake machine, or any other hydraulic machine. If you're not serious, just look at the diagram, so don't even worry about explanation. But I believe all those who are following me are serious physics students. Now, also, if you want, or let me make this simple thing for you. In all these applications, you will hear me, or any other physics teacher, or anybody else who knows what's explaining using the word atmospheric pressure. It is possible we can do all this because of atmospheric pressure. Look at this. A syringe is one of the apparatus, or let me say instruments, or that can be used to measure volume. You can see it right now here. 5, 10, 15, 20. They ask you in church, hey, which church now? In hospital, how old are you? You know the kind of people who like lying in their ears. So somebody is 35 and says I'm 22, I'm 16. They will give you a injection. The volume of the liquid medicine that you will be injected will be that of 16-year-old person. Yet you are 35. You are supposed to be given full, or they look for another big syringe, the one that can accommodate medicine that can go with your age. So now look at this. You know, the doctor can easily fill it with medicine. Very simple. You know what? Look at this diagram. There must be atmospheric pressure to aid or to help in filling the barrel or the syringe with medicine. When you pull the piston rod backwards, it creates a vacuum inside the barrel, or it creates a low pressure region inside the barrel. This makes the greater atmospheric pressure outside to push the liquid medicine inside the barrel. And very simple. And when they want to inject, first they ensure that the syringe is inside you, inside your body, inside your skin. Then now they just press down the piston rod. The greater pressure inside the barrel would push medicine against the low pressure of your blood in the body. If you don't apply pressure at the piston, in fact, opposite will happen. The blood will be drawn from your body. And if they want to draw blood from your body, they simply apply the same process. First, they ensure the syringe, but by then the piston is down here. The piston is all down there at the barrel. Then the syringe is inside you. Then they pull back, creating a low pressure region compared to the pressure of blood inside your body, then the blood will be just removed from your body. As simple as that. That is about syringe. Please don't fear being injected. I know people fear. I may not be an exception case, but I'm saying you people don't fear. Yes, look at this bicycle pump. It operates in the same scenario. It has a leather washer that behaves in two ways. When you are pulling the handle backwards, the leather washer allows air to get in. You see these arrows? It allows air to get in when it's being pulled backwards. But when now you are pushing it forward, those leather washer will act as a valve. Then it pushes the air to the bump or the ball. So these leather washers are so important. Sometimes when you are doing your work, it overlaps. It overturns. Is that English? Which word can we use now? English. Okay, it overturns. Then you have to put it outside. You put it very well. Then again, continue pumping. So you have two processes. Pulling back to allow air get in. Then pushing forward. The air that had been allowed in kama mteko. The air that had been allowed inside, now the leather washer could not allow it get outside. But they are being pushed against the pressure. As the more you push, the more the pressure inside the barrel increases compared to the pressure of the ball or the tire of the bicycle. Then it just enters the other side. And of course, at the ball or the tire, it has a valve that allows air only inside, but not outside. Yeah, you can write this short note in your exercise book about bicycle pump. Now lift pump. Lift pump, it has upstroke and downstroke. Just to look at the diagram, and please do not confuse lift pump with force pump. I'm starting with lift pump. Force pump will follow after this. It is the next one to be discussed. Then I give you like 15 questions about pressure. You calculate, then you take it to your teacher to mark it for you. If I'm your teacher, I always say bring it to me. Lift pump. Before you start everything, first of all, you pour some water here. Hapa kwanza unaweka maji kwanza. Before once press up or down, unaweka kwanza maji hapa. Yes. And there are two valves, the S and the R. You can see we have valve R and valve S. Now, then we have the plunger. Plunger is the one responsible by moving upwards or downwards. Pia hapa ni kama mteko tu. Just to see how I'm explaining this. When the plunger moves up, ikienda juu hivi, what happens? When the plunger goes up, valve R will close. Valve R will close because of the weight of water above it. In uliweka, the one you poured it before you start pumping it. When valve R closes, the pressure between R and S becomes very low compared to the atmospheric pressure outside. So the atmospheric pressure will push water in, and valve S allows the water in. The valve S opens during upstroke or when the plunger is made to move upwards. So just understand, when the plunger is made to move upwards, what happens is the R closes because of the weight of water above it, while S opens and allows water to get in. Then downstroke. When you brace it downwards, S is the one that will close. S is the one that will close. Why? Because of the weight of water above it. Then that weight of water above it, above S, is the same water that will open valve R. And when they open valve R, all the water in between R and S will get out via valve R and just pour outside using the side tube. Very simple explanation. Don't confuse your own other things. Look at the difference now with the force pump. The force pump is here, but of course the force pump is more advantageous compared to the lift pump. In practical, now let me give the two limitations of the lift pump. In practical, the possible height of water that can be raised by this pump is less than 8 meters. It is 10 meters, sorry. It is 8 to be 10 meters, but in practical it is less. It is 8 meters somewhere there. Because of low atmospheric pressure in places high above sea level. That one we know it. Leakage at the valves and the pistons. Even if we are saying that the valve R sometimes closes, it doesn't mean that it at all cases it cannot allow water to pass through, or during the downstroke when valve S is expected to close, sometimes it leaks, it allows some water which is not supposed to be. Yes, force pump is, as you are seeing here, it has two valves, as you are seeing, G and F, or whatever the case. It can be, in my diagram I've just put some letters there. Just to look at this, we have the upstroke, then the downstroke. During the upstroke, when you push this plunger upwards, in between valve F, the pressure will be very low, and the atmospheric pressure will push water in as the valve F opens. When it opens now, it allows a lot of water to get in. But once you change now the stroke, it becomes downstroke. F closes immediately. And when you push it, the water will have nowhere to escape, but they go through or to G. They just go to G. And that is how they get out of the well. And it is advantageous to work with this force pump. It enables continuous flow of water. That's one advantage. The height to which it can raise does not depend on the atmospheric pressure. Yes. Factors affecting the working of the pump. Amount of force you have to apply. If you put more force, much volume is produced or is raised. Ability of the pump and its working parts to withstand the pressure of the column of water in Jumper C. So you need to find the one. I heard some people saying German machine. I don't know which one is fake. I don't want to mention somebody so that you start saying Tinachukia Steward. No. If your spare parts are original, it can withstand the high pressure. Those four are the applications. Add siphon, add hydraulic brake system. So that is it. Now, allow me to present to you some questions. There is this diagram here. I'm not going to answer any question. I'm just presenting to you the question that is the assignment. Or, if you are feeling like you want me to do for you the questions, let me ask you, is the assignment for the teacher or for the student? If it is for the student, then do it. The figure below shows a lift pump. Explain why, when the piston is pulled upwards, valve A opens while valve B closes. If you have forgotten, go back to my explanation, you will get this. Explain why, when the piston is pushed downwards, valve A closes while valve B opens. After several strokes, water rises above the piston as shown. Another one is here. State how water is removed from the cylinder through the spout. You are a physics student, explain. A lift pump can lift water up to a maximum height of 10 meters. Determine the maximum height to which the pump can raise paraffin. Here you have to involve calculation. You have been given the various densities of water and paraffin. State one factor that determines the height to which a force pump can lift water. Let's go back to our previous slides. You will have this. Now, these are the general questions. That I've been giving you, I mean concerning the whole topic. Let me not read for you. You can read it for yourself. You can copy them. Then after copying them to your exercise books, try to do them. Yes. If you cannot do it, go to the comment section of this video and say a revision exercise question 3. I will do it for you. My team will do it for you and show you how to do it. So just you post the video and then you copy. That one is there. That one is up to question 11. You simply post the video and you copy the questions. Yes, another one there. You simply post the video and you copy the questions. Question 15 is there. Do what? Post the video, copy the questions. Very nice questions. Please do them. You will meet them in your exams. Yes. Otherwise, thank you. Let's get to the next video, particulate nature of matter.